Dear viewers, we have with us Professor Mayank Srivastava, who is Chair of Electronics System Engineering Department of IISc, and he has come up with the innovative product development in gallium nitride area. So, sir, please brief us about gallium nitride and its development that you have come up with.
So, broadly, gallium nitride is one of the semiconductors among various semiconductors that you're aware of, such as silicon, silicon carbide, gallium oxide, and their range of semiconductors.
Okay.
Gallium nitride falls into what is called wide bandgap semiconductors.
Okay.
So, in the semiconductor context, the band gap is basically the gap between what is called valence band and the conduction band, and higher the band or higher the gap allows the material to sustain higher voltage or the electric field. So gallium nitride has promising properties, particularly for power applications, whether it is power electronics or whether it is power RF electronics.
Okay. Okay. Right.
The
Specifically coming to its application, can you tell how it will disrupt the EV vehicle market and these data centers? What are the application GaN will have going forward?
Yeah. So basically, power electronics or power electronic systems are not new. I mean, the power electronic products do exist for more than 50 years as far as the silicon semiconductors are concerned, and they do exist for close to a century since when the switches were available. But how the gallium nitride is going to change the field or bring the breakthrough in the field is, so every power electronic system or every power electronic product, the size and the weight depends on the certain properties of the power semiconductor device. So if you take a silicon device and you compare that with gallium nitride, the gallium nitride allows you to basically switch the device or run the circuit at much higher frequencies compared to what silicon can enable. Now, this frequency of operation directly translates into certain aspects such as efficiency, weight, size, or even the volume the power electronic system occupies. On top of that, it also enables operations at much higher voltages compared to what silicon can enable if you have to benchmark in terms of the operational capabilities or efficiency or frequency.
Okay.
So now with gallium nitride, these systems are going to be much more smaller, lighter weight with much higher efficiencies.
Okay.
Say for example, electric vehicles. If your electronic system, suppose a converter, right, or those systems, those modules which are driving the wheel, if they are consuming a lot of power, they are wasting a lot of power, you will not be able to drive for very long. So what you need is systems which have much higher efficiencies, so that you are not losing a lot of battery power which is stored. So that is one aspect, which is efficiency. The other aspect is the speed at which the runtime that you get per charge. That is also a function of the weight of the system.
Okay.
Now, if you are able to reduce the weight of the system, size of the system, then you are also going to run longer per charge. And on top of that, if you are able to miniaturize these power electronic systems, you can pack them in a much more efficient way compared to what you can do with, say, silicon kind of devices. Now, on top of that, they are also thermally efficient. So you also basically gain a lot in terms of thermal aspects.
Okay, very good.
Now, this is the fundamental property of GaN, but it comes with a lot of challenges, and these are the challenges which the community or the industry worldwide are trying to address before they can be deployed for EV or data center kind of applications.
Okay. So can you tell briefly, you already mentioned some of these things, but fundamentally, which are all the main challenges that you resolved and which you want to highlight as your fundamental research activity?
So I would say broadly there are two challenges which the industry worldwide is trying to address. One is the what is called reliability of these devices.
Okay.
Now, reliability in general is a term which explains that, in simple sense, how reliable the device is. So, how reliable the device defines how reliable the system will be. And in this case, reliability means for how long the system will work or the device will work without fail, or without changing its performance, right? Or without changing its behavior or drifting its behavior. Now, this is there with pretty much every semiconductor device or pretty much every product out there, right? Reliability is a very fundamental qualifier. Now, the problem with GaN is, since it's a very different material system, whatever reliability learnings the industry acquired with, say, silicon over past 50 or 70 years, all that learnings does not work with GaN. A majority of that learning does not work with GaN. GaN is more complex and you have to acquire newer learnings. Now, that newer learning requires more fundamental explorations, and only when you understand various ways in which the device can degrade or fail, right, you can solve these problems at a technology or a process or a design level. So now that is one big challenge that we have broadly addressed in our works. Not only these works which have come out in the light, but even previous works. The other big challenge with GaN is, and I'll put this in a layman's way, is suppose you're making a wall, right? Now every wall maker, I mean, we are building a home and you have to build walls, right? So everyone knows how to build walls with, say, cuboid or rectangular bricks. Now suppose suddenly I give you another brick design which looks spherical, and I tell you that if you build wall with that, it is going to be much more stable. But you don't know how to build a wall with a spherical brick, right? Theoretically it will be more stable. Again, don't assume that spherical brick will give you stability, but I'm just giving a layman assumption, picture, right? But you don't know, so you're not comfortable, right? So even if something exists which can make the walls more stable, I'm more comfortable going with a rectangular brick, because this is the conventional principle, and everything else is around that. The same happens here, right? So for example, the conventional silicon power MOSFETs, silicon carbide power MOSFETs, they have a certain threshold beyond which they will turn on. These transistors in power converters and power electronic system, they work as a switch. So they have a certain threshold beyond which they will turn on, and they have to have a certain threshold up to which they can make the device in the on state. Now for GaN this was limited. So the threshold, which in case of switches called threshold voltage, was a very low number, and the maximum voltage that you can also apply at the gate, so gate is the terminal through which you turn on the switch, was also limited. Now that hindered its application, or that has been hindering its application in majority of the areas, particularly the high demand areas such as EV or data center. In case of EV, it is the reliability which comes with the threshold voltage and various other high power aspects. In case of data center, it is the noise which comes because of the high frequency operation. Now if now we have given a proposal, we have kind of at a lab level we have demonstrated the solution. If this is scaled up, this can basically enable I would say deployment of GaN in these particular sectors.
Oh, fantastic. So coming back to your fundamental research activities, how much time you took for this GaN, this kind of an innovation ecosystem here in IISc and your team members, and about what we call filing of the patent? Broadly give us an overview so that our viewers will be what we call further excited, and they will also spawn a lot of research activity out of Professor Mayank Srivastava.
Well, I have spent more than 12 years now in IISc. As far as the GaN research is concerned, I think I have been working on GaN for more than 10-11 years now.
Very good.
But as far as the power semiconductor device research is concerned, I have now close to 20 years of experience.
Wow.
GaN is relatively newer, so of course when I moved back from industry here, where I did a lot of work on power devices, silicon power devices, I started working on GaN. on your question on how much time this research took, well, this particular research that we have published recently would have taken maybe a couple of years, but everything builds on top of each other. So I would say it's the accumulative experience which has resulted to us getting a point where we can even come up with ideas to solve pertinent problems that the industry is trying to solve. As far as my group is concerned, I think there are several students who have already been graduated. They are around the world now in say leading positions across different industries working on GaN. Broadly, my group works on various things other than GaN as well. I mean, we work on 2D materials, we work on a lot of silicon device technologies.
Oh, very good.
And GaN has been a major, I would say, component of my group's activities.
Okay.
And I hope you will also interact with my students and
Definitely,
they'll contribute more.
So here I want to ask you a specific question, because from lab to industry, so how much time it will take for GaN to have an impact in India and across the globe, and India become one of the leading ecosystem enabler in this very space, and what you want exactly from the government of India so that we can do a lot more impactful activities, so that India should be looked upon for GaN related activities across the globe. So what do you want from the government of India, and how you are planning to deploy this solution from lab to exact markets? Please broadly explain to us.
So there are multiple parts of your question. Let me talk about how much time this technology will take to get to the market.
Absolutely.
Now the answer depends on, the number depends on what kind of setup adopts this technology.
Yeah.
So suppose if this is adopted by a prototyping center,
Okay.
which converts into a lab scale innovation into a prototype, it would be another 2 years.
Another 2 years, yeah.
And then and at that stage, if it is licensed by industry, it would be another 1 year to basically do further fine tuning and make it reliable and commercially viable.
Okay.
I would say 3 year would be a good time frame for this technology to touch the market if the right resources and the support system is in place.
Okay. Very good.
As far as the proto center is concerned, we already have the proto center.
Okay.
In fact, Ministry of Electronics funded a proto fab, which we have in IISc. What we don't have industries. I'm talking about large players,
Okay.
Who can acquire these technologies and convert into commercial products.
Wow, fantastic. Okay.
So what we need in the country is, we need more GaN players, more GaN industries, which can either build their own technologies and commercialize, or collaborate with people like us and acquire the technology and convert that into something which is commercial scale and commercialize. So, but let me also tell you that I think under the India Semiconductor Mission, these things are already in the pipeline. So I am quite hopeful that sooner or later we will have a few large GaN manufacturers who will set up shops in the country. And when they do, I only hope that they are not limited to a licensed technology that they manufacture here and then sell. They are also interested in, and they are also investing on acquiring newer and better technologies and convert that into commercial scale and commercialize from India for the world.
Okay. So now you have made it very clear that Indian Semiconductor Mission and the Quantum Computing Mission, two of them are good enough for you to get into the next orbit, to take this innovation to the next orbit, or you want something else from Department of Science and Technology, or the involvement of a DRDO or ISRO or something like that. What is your take on that? Because we are not working on old method. We want to have a new landscape. So Professor Mayank, we want you to take it to the next level, so the policymakers, the administrators should open their eyes to come up with what you want exactly.
So I think what India should do is, there should be a big program on GaN. I'm not saying that GaN has not been funded in the country. DRDO has funded GaN.
Very good.
DST has funded GaN. Ministry of Electronics has funded GaN.
Yeah.
But what has not happened so far is that the government has not come up with a large GaN program or say wide bandgap semiconductor program. Or even if there is a electric vehicle or e-mobility program in the country, GaN was not part of it. Unlike GaN being part of it or wide bandgap semiconductor being part of it in similar programs around the world. So what we need is a robust program on, I would say, electric mobility or electric vehicle in which the GaN is part of it, or if not that, at least a dedicated program on GaN, which which focuses on funding research, which is from mid-scale TRL to high-scale TRL, and delivering technologies which can be licensed by industries and converted that into commercial technologies.
Amazing.
Now, something like that is missing in our country, and we need that.
Okay.
Otherwise, what will happen is academia can produce research only up to a certain level.
Yeah.
And it's also not academia's job often where they would produce something which is high TRL. Few people in academia do, which should always be promoted, but not everyone will do. So if you have a program where basically everyone come together and work on some common problems and push GaN roadmap from the mid TRL to which academia can achieve to high TRL, and then also bring some of the industries on board who are possibly going to set up shops in the country where they sign up to licensed technologies. I think if something like that happens in the country, we would have a very good roadmap where then we can basically say we have GaN for the world.
So, Mr. Professor Mayank Srivastava has set the tone for India's GaN ecosystem building. So, he has made it very clear that the policy makers, the academia and larger industry community should be part of this journey, and Fortune 500 companies, simultaneously our MSME companies, should join hands with him. So, sir, all the best for talking to NFAPostTV, for divulging all this information. We will continue our engagement with you.
Sure.
Thank you.